The question reads that the V versus I graph of a conductor at two different temperatures T1 and T2 are as shown in the figure. This question was sent by several students as doubts. Just see it. Then T2 minus T1 is proportional to. Just look at this graph. It is given that this is V, the vertical axis, and this is I. So V versus I graph at two different temperatures T1 and T2, they are given. So what we conclude from this graph? The graph is a straight line. This implies that Ohm's law is valid for this particular conductor, because at some particular temperature the V versus I graph is coming to be a straight line. So this implies that the resistance, which is equal to V by I, and this V by I should be equal to slope of the graph, the slope of the straight line graph, is it not? So for the first graph at temperature T1, what is the slope? Slope is equal to tan theta, is it not? The graph is making an angle theta, and this tan theta is equal to V by I, that is equal to R1. The temperature T1, the resistance is R1. So the same conductor which will be at 0 degree Celsius, if its resistance is R0, so we can write it as R0 into 1 plus alpha times T1, where alpha is the temperature coefficient of resistance, is it not? Where alpha is the temperature coefficient of resistance. Now here, proceeding in the same manner, at temperature T2 we can have the slope is equal to how much? The angle that it makes will be 90 minus theta. So it will be equal to tan 90 degree minus theta. This the resistance is R2, and that is at temperature T2. So it is R0 into 1 plus alpha times T2, is it not? I hope that you understood that where from 90 minus theta comes, this will be equal to 90 degree minus theta. So hence we can say that at temperature T1 and at temperature T2 we got the two resistances, is it not? Now they have asked the temperature T2 minus T1 is proportional, so I need to actually subtract it. If I take this as first expression and if I take this as the second expression, if I subtract, then what will happen? I will get an expression for T2 minus T1. So I will be subtracting, let us say first from second. So I will be getting R2 minus R1, that will be equal to, here tan 90 minus theta is cot theta, so this side it will be equal to cot theta minus tan theta, and that we are getting it as R2 minus R1, and that side R0, 1 plus alpha T2 minus R0 times 1 plus alpha times T1. And there, proceeding, it's a simple trigonometrical simplification. Let us do it as cos theta by sin theta minus sin theta divided by cos theta, and at that other side you take R0 common, you get 1 gets cancelled, and we get alpha times T2 minus T1. So here, proceeding further, what we get, it will be equal to cos square theta minus sin square theta divided by sin theta cos theta, and this side it is equal to R0 alpha into T2 minus T1. By this time you are able to look at this particular result. So what I will be doing is, let me put 2 here, also divide by 2. What it will give? It will give the denominator as sin 2 theta and the numerator as cos 2 theta. So we get cos 2 theta divided by sin 2 theta, and this is equal to half R0 alpha and then T2 minus T1. So what we get? We get that T2 minus T1 is proportional to how much? It will be proportional to cos by sine, that is cot 2 theta. So which option is correct? The option third is correct. T2 minus T1 is proportional to cot 2 theta. Thank you.